Hi everyone! Welcome back to our Coding for Chemistry series. Today is going to be super useful. We're talking about lists and tuples. Think of these as your digital lab organizers, essential for keeping your experimental data, element lists, and reaction parameters in check. By the end of this video, you will be able to understand what lists and tuples are, recognize how they look and behave, manipulate them, use key methods, and know when to choose a list versus a tuple. And don't worry, I won't bury you under every tiny detail, just the essentials to keep you alive, or at least in a low-energy, excited state. Let's get started. So, first question, what do these things even look like? Lists and tuples are collections of multiple values separated by commas. Lists use square brackets, tuples use parentheses. They can be homogeneous, all one type, like a list of integers, or heterogeneous, mixed types, like a list containing a string, a float, and an integer. We can create empty containers with square brackets for lists, parentheses for tuples, or use constructors. Quick one-liner you'll use a lot, turning a range into a list or tuple. List, parentheses, range 10, where you create a list 0, 1, 2, 3, and so on. Tuple, parentheses, range 10, where you create a tuple from 0, 1, 2, and so on. And you can convert between them very easily. Yes, Python is very chill about conversions, like a chemist casually switching from Celsius to Kelvin. Lists are ordered, meaning they remember the order you put things in. Heterogeneous can mix int, float, string, even other lists. Allow duplicates. 1, 2, 2, 3, 3. Totally fine. Mutable, you can change them after creation. And dynamic, they grow and shrink whenever you want. So think of lists as flexible lab notebooks you can keep editing. Tuples are similar to lists except for one big rule. Tuples are immutable. Once created, you cannot change, add, or remove anything. Tuples are basically the read-only version, like the label you stick on a reagent bottle. Once it's printed, it stays that way forever. This is great for data you should not accidentally mutate, things like atomic symbols, physical constants, etc. Nesting, very common in chemistry data. Nested structures are super common when you're handling multiple trials, multiple species, or spreadsheet-like data. You can put lists inside lists, tuples inside tuples, or mix them. Take a look at these examples, so you can structure related data together, for example, variable names and their values, or concentrations and species. Indexing works just like strings. Positive index starts at 0. Negative starts from the end. -1 equals last item. With a tuple, so you can combine indexing to drill into nested structures. Handy built-in functions work on both lists and tuples. Len equals number of elements. Max equals largest element. Min equals smallest element. Sum equals sum of elements. Works for numerical data. Sorted equals return a sorted list. Default is ascending order. To get a new sorted list in descending order, use reverse equals true. Sorted always returns a list, even if you pass it a tuple. Want just a portion of your data? Use the syntax start, stop, step. Works exactly the same on tuples, just returns a new tuple. Concatenation and repetition work like they do on strings. Concatenation plus glues two collections together. Here I've shown a method to give multiple statements on a single line. Quite handy. Repetition star repeats the collection. This is where lists and tuples part ways. Modifying list elements by assignment. Tuples are not mutable. For the tuple T equals 1, 2, 2, attempting assignment T1 equals 25 throws type error, tuple object does not support item assignment. This is intentional. Tuples protect your data from accidental changes. So if something needs to change, don't put it in a tuple. You can create a reversed copy of a list or tuple with slicing with a negative step. The original object is not modified. With a tuple, so ::(-1) is like a quick reverse this sequence for me trick. List methods are functions attached to the list object itself. They mutate the original list in place. They make the list grow or shrink in place without creating a new list. Important, adding methods. Append adds item to end. Insert index, item inserts item at index. Extend iterable adds each element individually. Extend input must be an iterable, otherwise type error. Append list adds the whole list as one item. Append is like putting a whole beaker inside another beaker. Extend is pouring the contents. You can think of .extend as the augmented concatenation operator, like plus equals for lists. Achtung! Append modifies the list in place and returns none. So if you do new list equals list.append item, you are assigning nothing. Removing methods. Quick overview. Remove value removes the first occurrence of value, raising value error if not found. Pop index removes and returns the element at index, last element by default. Clear removes all elements from the list. These are handy for cleaning or trimming datasets, like when you want to remove outliers or bad records. More list methods you'll use constantly. Index function returns the position of element, first occurrence only. If it doesn't exist, Python raises a value error. Count function returns number of occurrences of the argument, handy when analyzing data or checking for duplicates. Sort function sorts list, default in ascending order. For descending order, you guessed it, use reverse equals true. Reverse function reverses the list in place. Copy function returns a shallow copy of the list. These two are useful when you want to modify, order, or duplicate a list without linking them. Need to check if a reagent is in or not in your list or tuple? Iteration. Yep, lists and tuples are iterables. Whether it's a list or a tuple, you can iterate the same way. List comprehensions are a compact way to build lists, often from existing sequences. This is the Pro-Chemist way to transform data. Basic syntax is bracket, expression, for, item, in, iterable, if, conditional, bracket. Example, convert temperatures in Celsius to Kelvin. Another example, all odd numbers from 1 to 9. This is often more readable and shorter than writing a full for loop plus append. It's fast, clean, and makes you look like a wizard. Tuples pack values together. You usually see them with parentheses, but parentheses are actually optional when creating a tuple. Tuple unpacking. Since tuples are ordered, you can unpack them into separate variables. Important rule: the number of variables on the left must match the length of the tuple on the right. Also, the variables on the left are not a tuple. They're just multiple variables listed in order, even if you add brackets or parentheses. So those parentheses or brackets are just for readability. They don't make the left side a collection. Parallel assignment. You can pack and unpack in one line. A, B, C equals 1, 2, 3. Here, the right-hand side is a tuple, but the left-hand side are just 3 variables. Or use it in a loop with nested data. This is so clean, way better than indexing I, 0, I, 1, I, 2 everywhere. You can even write parentheses, num, symbol, mass in parentheses inside the comprehension for readability. But again, those parentheses are just cosmetic. They don't create a tuple there. Because parentheses are optional for tuples, the comma is what actually makes a tuple. Because tuples are immutable, they only support 2 methods, count and index. Usage is identical to lists. General usage recommendations. So when should you use a list and when should you use a tuple? Use lists when you need to change, add, remove items. Size will change, appending measurements, etc. Mostly homogeneous data. All pressures, all times. Use tuples when data should never change, atomic weights, physical constants, function return values. Storing heterogeneous records, e.g., atomic number, symbol, mass. You want accidental modification protection. Returning multiple values from a function. Function return values are often tuples because they nicely pack related but different pieces of information. So that's a tour of lists and tuples in Python, with some chemistry-flavored examples. Lists are flexible, tuples are fixed. Use them wisely and your code will be as clean as a freshly washed beaker. And here's a sneak peek. In our next video, we'll explore applications of lists and tuples to some really interesting chemistry topics. If you found this helpful, give the video a thumbs up, subscribe for more coding for chemistry lessons, and share it with your lab mates, because coding is way more fun when you're not doing it alone. Thanks for watching, keep experimenting both in the lab and in your code, and I'll see you in the next one.